Hello students, this is Dr. Anita Raj, Geochemistry mentor, welcoming you for another session in polymers. Today we are going to see an interesting topic, that is a mechanism of cationic addition polymerization. Okay, what is a cationic addition polymerization? Actually, this type of polymerization, this involves positively charged carbonium ions as the chain carriers. Okay. In the case of the free radical mechanism, we had the active centers. Here, we are having the positively charged carbonium ions. Okay. So these positively charged carbonium ions act as the chain carriers. Okay. This cationic addition polymerization is also having another name, that is carbonium ion addition polymerization. Okay, since because this involves the positively charged carbonium ions as chain carriers, this cationic addition polymerization is also having another name, that is a carbonium ion addition polymerization. Okay, and actually this type of addition polymerization is catalyzed by Lewis acids. Okay, let me give some examples for this Lewis acids, that is AlCl3, aluminum chloride, okay, and then TiCl4, BF3, boron trichloride, okay, then is SnCl4. And we are having so many other examples as Lewis acids, and normally these are the different types of Lewis acids which we are using for catalyzing this cationic addition polymerization. Okay. This cationic addition polymerization takes place at a very high rate, even at a very low temperature. Okay. So, for example, the polymerization of isobutene. When you're taking into account the example isobutene, polymerization of isobutene, this gets completed at minus 100 degrees centigrade in a few seconds. Okay, it's possible to complete the polymerization of isobutene at minus 100 degrees centigrade, and that also it takes place in a few seconds. Okay, so that's why it's given that this type of addition polymerization, that is a cationic addition polymerization, takes place at a high speed at low temperatures. Okay. Now let us see the mechanism of cationic addition polymerization. See, this type of polymerization also involves initiation, propagation and termination steps, just like that of a free radical mechanism. Okay. See here we have initiation, then propagation and then termination. So all these three steps are involved in this mechanism of cationic addition polymerization, and let us see one by one. Okay. Actually, I'm going to explain this mechanism of cationic addition polymerization by taking into account the polymerization of isobutene in the presence of BF3. Okay, so let us see what is happening in the case of initiation. That is the first step. As the strong Lewis acid BF3 first adds a molecule of water to form BF3 water molecule. Okay, this is an adduct, and this attacks an isobutene molecule and forms an carbonium ion. So what's the first step? Actually, this BF3, this first adds to a molecule of water and it forms a BF3H2O molecule. Okay, and then this BF3H2O, this attacks the isobutene molecule and forms a carbonium ion. This is what happening. Actually, in initiation, we are having two steps. Okay, let us see what is happening in the first step. Okay, BF3, this attacks water molecule. Okay, it attacks water molecule. Actually, it is a reversible reaction and it forms an adduct, BF3 dot H2O. Okay, so this is the first step taking place in initiation, and we are getting an adduct. Now what happens in the second step? This BF3H2O molecule, it attacks isobutene molecule, and it forms a carbonium ion. Okay, so let me write the isobutene molecule now. CH2 double bond C CH3 CH3. So this is isobutene. Now this isobutene, now what happens? This BF3 dot H2O, this attacks this isobutene molecule. This attacks the isobutene molecule. One of the hydrogen ion, that is H plus ion, will be joining this CH2. Okay, what happens to this H2O? This gets dissociated like H plus OH minus. Okay, and now this H plus, this attacks the CH2. So now what is happening? This is becoming CH3. Okay, CH3 single bond C CH3. Okay, and again I'm writing this CH3 here. Okay, so this becomes CH3. Since the H plus ion is attacking here, we'll get a positive charge here. Okay, so plus. Okay, now let us put a plus here. Dot BF3. We should write the rest of the things. Okay, we should write up the rest of the things. BF3 OH minus. Okay, because H plus has gone here, so remaining out of H2 will be having OH minus. So we are having OH minus. So this is the carbonium ion. Okay, what is the name of this one? Carbonium ion. Okay, so as I told you earlier in the beginning, that is, this involves the formation of a positively charged carbonium ion. That's why it is called as carbonium ion addition polymerization. Okay, so now let us see what is happening in the propagation. Actually, in the propagation, the carbonium ion formed in the first step, that is initiation, attacks the second molecule of the monomer. What is the monomer we have used? Isobutene. Okay, so the carbonium ion which is formed in the initiation step attacks the second molecule of the monomer and forms a dimer carbonium ion. Okay, now this dimer carbonium ion further attacks the third monomer, that is third isobutene molecule, and forms a trimer ion. And this goes on and this process continues till a polymer ion is formed. Can you understand? So let me mark it. So the carbonium ion which is formed in the first initiation step attacks the second molecule of the monomer. What is the monomer? It is the isobutene. Okay, we are using isobutene as the monomer, and it is forming a dimer carbonium ion. Okay, and this dimer carbonium ion further attacks the third monomer, which is the third monomer. Again, it is isobutene, and it forms a trimer ion. And of course, this process will be going on as an endless process, and this continues till it forms a polymer ion. Okay, so let me write down the step 2, that is propagation. Now let us have the carbonium ion which is formed in the first step, CH3. This is the carbonium ion which is formed, is it not? Carbonium ion which is formed in the initiation step. Now this attacks another monomer molecule. What is the monomer molecule? Of course it is isobutene. CH2 double bond C, CH3, single bond CH3. Okay. Let me explain what is happening in the propagation step. Actually, this CH2, this gets added up to this carbon. This CH2, this gets added up to this carbon center, and this positive charge will be shifting to this carbon. Can you understand? This CH2 will be added up to this carbon, and this plus charge will be getting shifted to this carbon. Okay, and again we are getting another attack. Let me write the product CH3, single bond C, CH3. See here, this CH2 is going to add up to this carbon center. Okay, so again here single bond CH2. So here again single bond. Okay, this becomes a single bond, and we are writing carbon here. Okay, this carbon I have written, and this positive charge gets shifted. Okay, let me give the arrow mark. See, this is getting added up to this, and this positive charge is going to this carbon. Okay, so now what happens? Well, this carbon will be getting a positive charge. Okay, C plus. And now we should write the CH3 and the CH3 to this carbon. Okay, so CH3. Okay, CH3. Then we should write this BF3 OH minus also. So dot BF3 OH minus. So what is this? This is a dimer carbonium ion. Okay. See here, this dimer carbonium ion further attacks the third monomer. This third monomer again, it is isobutene, and it forms a trimer. Okay. So I am writing the isobutene again. I am adding up an isobutene. Okay. What is isobutene? CH2, CH2, double bond, single bond C, CH3, CH3. Okay. Now let us see what is happening. Again, this CH2 gets added up to this, and this positive charge will be coming here. Just like here, okay? Just like the same procedure, the CH2 will be getting added up to this and this plus charge will be coming and joining with the C. Okay, again we will be getting adducts. Okay, so here it will be getting added up and this positive charge will be moving to this carbon. Okay, let us write the product now. CH3, single bond C, CH3, CH3. I am writing this, okay. Single bond CH2, single bond C, CH3, again CH3. We are having the CH2. We are adding the CH2 here. So CH2, single bond C, CH3, CH3, positive charge dot BF3 OH minus. So this is a trimer. So we have got a trimer. Okay. Now what happens? Trimer carbonium ion. This trimer carbonium ion will be now getting added up to n number of these monomers. Okay. This will be getting added up to n number of monomers and will be getting a polymer carbonium ion. See here this molecule, this CH2, CH3 is getting repeated. Is it not? So 3 times it's repeated. That's why it's called as a trimer. Here 2 times it's repeated. So it is dimer. Can you understand? Now, this a trimer carbonium ion, this gets added up to a number of monomer molecules and finally we are getting a polymer carbonium ion. Okay. So now this gets added up to CH2, double bond C, CH3, CH3 and that to n number of molecules. Okay. And finally we will be getting the product like, let me write here CH3, again let me write it in a bracket CH2, single bond CH3, this is isobutene molecule, okay, again N, CH2, single bond C plus charge, CH3, CH3 dot BF3 OH minus. So this is a polymer ion, carbonium ion. Okay. So the final one is the termination. Actually, in the case of termination, removal of active centers takes place. Okay. So let me write the polymer carbonium ion now. So this is the polymer carbonium ion that is formed with the propagation step of this cationic addition polymerization. And what happens here in the case of a termination? See here, the one of the hydrogen atom from this center, carbon center, will be joining this OH minus. Okay, one of the hydrogen atoms will be joining this OH minus, and this active center will be removed from this. Okay, so that we will be getting the final product. Okay. So now let us see what is happening. So let me write the end product. I am writing the same whatever given here. So I have written everything whatever given here and finally I am shifting one hydrogen from this carbon center to this one. So automatically this becomes a C, in this CH3 becomes CH2. Okay, and this is becoming CH2. So this is the final product. We are getting a polymer plus BF3 dot H2O. We have separated the active center from this carbonium ion. Finally, we have got the end products. Okay. So this cationic addition polymerization is used in the polymerization of ethylene, isobutene, styrene, and then vinyl ethers, butadiene, etc. etc. Okay. So polymerization by this mechanism is most important for isobutene and alpha methylstyrene, which otherwise cannot be polymerized well. Can you understand? Well, fine students, I hope you might have understood what I have taught today. Let me meet you with another important topic in my next session. Until then, it's Dr. Anika Raj, your chemistry mentor signing off from it. Thanks for watching.